Hello everyone. So the topic that we will discuss in this video is universal law of gravitation. And before understanding this topic, I have some questions. The first question is, what is the force that is holding our planets around the sun? Second question is, what is the reason or why the tides are formed in the oceans, and what is the force that is holding the atmosphere here? The reason of all these questions, the explanation is hidden behind this law of gravitation. So we will understand the law of gravitation in this video. So what is law of gravitation? The law of gravitation says the force is directly proportional to m1, m2 and inversely proportional to r square. What it means? The Isaac Newton told in universal law of gravitation that each particle experiences a force of attraction in this universe, and that force of attraction is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. What it means? Suppose we have two masses m1 and m2, and the distance between these two masses is r. Then according to this law, universal law of gravitation, the force of attraction between these two particles will be directly proportional to m1 and m2 and inversely proportional to square of the distance. If we will remove this directly proportional, then a constant will come, and the name of that constant is gravitational constant. So it will, when we will remove it, directly proportional sign, then G will come and m1, m2 over r square. Remember it, here this G is gravitational constant. Gravitational constant. Gravitational constant, and its value is 6.67 into 10 raised to power minus 11, and its unit will be, so if we have to calculate the unit of G, then what we will do, we will move this r square this side, it will become f r square, r will go towards this side and m1, m2 will come this side. So here by converting or by moving r and m1, m2 towards the other side of the equal to, we can easily find the units. So the unit of force is Newton, and the r is distance, so unit will be meter square, and m is mass, so it is kg square, and when it will go up, the value will be in negative, so unit will be Newton meter square kg inverse 2. Okay, so that will be our unit. That is the unit for gravitational constant. It is a constant value. So this is our law of gravitation. Some more important points are there. So first point is that this is a central force. Okay, important points. It is a central force. Central force. What it means? Central force means if we have two objects, for example this and this one is our second object, then the forces which are central forces will act along the axis which is common to both. So what it means, if we will draw a line and that will pass from the center of both the objects, that will give the direction of the force. So it means when the force will act on these two particles. And one more thing, you have to remember that the gravitational force is always attractive in nature. Okay, so it is always attractive in nature. Second point is attractive in nature. Attractive in nature. Okay, so what it means, if the two forces, if the in these two objects, when the force will act, this force, the gravitational force will act, then it will act along along this line, which will pass from the center of these two objects. That's why it is also known as the central force. And the third point and important point, it does not depend. Okay, it does not depend on medium in which two objects are placed. Okay, so remember, it does not depend upon the medium in which the two objects are placed. Suppose we have two masses m1 and m2. If we will place these two masses in air or in water or in any other medium, the value of force will come same. Okay, so it doesn't depend upon the medium or between these two particles. And fourth point is, it is a long range force. Okay, long range force. So what it means? Long range force means the range is very long. And what it means? The range, for example, if we will say the force between the sun and the earth, so the distance between the sun and earth is very long. So we say the force acts, this force acts on long range. And more example, the force between the earth and the moon. Okay, earth and the moon. So it is approximate, the range will be 1.5 into 10 raised to power 8 kilometers. Okay, so for a very long range, the force acts. For small range, it is not very effective. For small range, for example, if you will see, if you will see atom, in atom we have a nucleus and electron revolve around it. So here the gravitational force will not work. Remember it. Here the different type of force will act, that we will discuss later. But in this video we will discuss only the gravitational force. It is a long range force. So I hope the point long range force will be clear to you. And fifth point is, it obeys Newton's third law, or it have an action or reaction. So what it means, if m1, this mass m1 and this mass is m2, if m1 is acting force on this, then m2 will also act the same force on this. So it means equal and opposite forces they act. If m1 is acting force on it, if we have to calculate the force between m1 and m2, suppose the distances r, then m1 have a force F is equal to K m1 m2 over r square. This much force it will apply on it. Similarly, the m2 will also apply the same force on m1. Okay, so it means it have a action and reaction here. It have action and reaction here. Action and reaction here. I hope the whole universal law of gravitation will be clear to you. Okay, thank you.